Right, today we're going to talk about fonts, rasters and print formats in the CIJ printer, the continuous inkjet printer. So we'll start and we'll have just an overview of fonts. Everything that we do is bitmap printing. Whether it be a font, whether it be a logo, it is all bitmap printing. Bitmaps it's a raster type printing. Everything is printed in rows, nothing overlaps, usually, and it's a matrix. And you have your Y and your X coordinates, and you have stuff inside a matrix. We only print in one colour. That colour can be black, white, yellow, red, blue, green. But inside the printer, as far as it's concerned, it's a bitmap with bit on or bit off. It has no colours inside the printer, depends on the ink and the substrate you're printing on. So all of our bitmaps are two colour, and it's either bit on or bit off. So now that we know that everything is bitmap printing, all our fonts are drawn as bitmaps. So for instance, if we're going to draw an A, we might want to draw something like this. That would be, for instance, 6 drops high. And we've got, each one of these is a stroke, so we've got 4 strokes wide. That's the font we could use. That is drawn as a bitmap, and it's saved as a bitmap, even though it's a font. And all of that's put into the printer. The fonts that we use...
Saved at 1 bit per pixel?
1 bit per pixel. So inside the printer we have a series of fonts, and we use Unicode fonts. They are on different pages, but the file that goes together is one big file. So inside the one big file, there's headers and there's pointers, and the pointers point to different pages, and on different pages we have different characters. But what to get across is that each of those characters is a bitmap. So regardless of how the file is put together at this stage, each one is drawn as a bitmap, and we render it as a bitmap. So, the next thing to look at is the raster. In CIJ printing, for instance with a 60 micron nozzle, we have 64,000 drops pass through the nozzle every second, of which we could use all of them if we wish to. There are reasons why we can't, and that might become clear. So a raster is the voltage that we are going to put onto the drop. So we had our bitmap, and each one of these drops coming out of the nozzle. So we have a nozzle there, and these come out. Each one of these gets a voltage put on it. And that voltage is a charge which it absorbs, and then it is deflected to fall onto the substrate in a particular point. So the raster, for instance, if we had a small one, you have no drops printed. We could have 1 drop printed. We could have 1 drop printed there. We could have 2 drops printed. As you can see, we're building up a binary pattern here. So those are different combinations we could print with, for instance, a 3-drop raster. No drop, 1 drop, 1 drop there, and so on. With those, we could, for instance, build up a particular pattern to print. If we took those over there, and we put that beside it, and again, we could print a box. Each one of these drops here has a particular voltage. Now when we send the stuff out from the nozzle, that's the nozzle, there is a gutter because it's CIJ, continuous inkjet. Some of these drops go into the gutter and they're recirculated back around to come in. These drops having a voltage, also there's deflector plates to deflect it onto the substrate. These can have an effect on each other. Now we all know if you take two very strong magnets and try and push the south poles together, they repel each other. Okay, it's the same thing here. If we were to charge two of these drops and to charge them very hard against each other, or they'd either repel each other to pull away, or they could attract each other to pull together. If you're going to have two of these drops join, coalesce together, this one had 200 volts and this one had 210 volts, if this was to join together, we might get a very big one drop. So on the substrate, instead of having two drops fall like that, we would have a blob form like that. Not very good if you're going to be printing QR codes, data matrix codes and so on. We need the pattern to be very clear. So one of the things that we do in the raster is we start to introduce guard drops. So these are to guard the two voltages from each other. So instead of now just having two drops, we for instance could have four drops. This one here could still be 200 volts, this one 210 volts, but in between we might put some other voltages. That would mean that these two didn't attract each other or repel each other depending on what the voltages were. So we're neutralizing the effect of the drops on each other. These guard drops, they all go into the gutter. We don't use them. They go in with all the rest of the unused drops into the gutter. Now, each of these rasters that we produce has what's called a raster length. So that stroke, each stroke has a raster length. That means that is the number of drops we use in each and every stroke, regardless whether we print them or not. So if I gave that a raster length of 50, and I'm only going to be printing 3 drops, I still need 50 drops per stroke. Which means you'll obviously be printing a bit slower because you've got to get more out and charge them. So if you were, for instance, having a high quality raster, these are HQ rasters, you would put lots of guard drops in and you would neutralize the effect as best you can of the drops on each other. That means that a high quality raster will be slow. Its speed is slow. If we had, completely at the other end of the spectrum, a high speed raster, I will start to take these out. So my neutralizing effect is not the same. My print quality is a lot poorer, but my speed is faster. I should put quality at the end here as well. That's name. Quality is good, quality is poor, and it's fast. So that is kind of the two ends of the spectrum that we have. You either have a good quality, slow speed, or a fast speed but poorer quality than that. We're not saying it's bad quality, you can't read it, we're just saying in relation to the high quality, this one's going to give you poorer quality. In between that you can have lots of other things, and sometimes it's standard. It's a trade-off now, as you can see, between the speed and the quality that you've got. The higher the quality, if you've got a 32 drop raster, you want to print 32 drops, the amount of work you have to do on that is immense. It's hours and hours of work, making sure that you've got the right voltages in to neutralise the effects of them. They take longer to produce, and therefore if we're going to sell them, we charge more money for them. If you've got a smaller raster, like a 5-drop raster, those are the ones that we use in the very, very fast printing that we do. Doesn't mean it's any cheaper, but it costs less. So now we know a little bit about the raster, and we know a little bit about the font.
I've got one question.
Yes.
When we say 32 drop raster or 50 drop, does it include guard drop as well?
Those are the only printed drops.
So it means 50 plus all the guard drops?
Yes, that's the raster length. So the raster length that we had here was 50, but we only had 3 printed drops. So I would say that's a 3-drop raster in that example, not the 50. They'll give you very high quality, but as you can see the speed is slow. For the high speed, I'd probably have that at 4 drops with only 1 guard drop in there. So it'd be a 4-drop, but still a 3-drop raster, high speed. So when we have our item to print, something like the letter C, and I'm using only the 3-drop raster here, we can see that it's made up of different types of stroke. So when the printer reads this bitmap, and this is a very, very simplified version of what actually happens, it says, I want a stroke that looks like this. That stroke's a number 8, so it puts in, I want a number 8. Then it wants this stroke. That stroke happens to be number 7, I think we agree. And another number 7. So the letter C then becomes these, which then it goes to look up in a raster table the voltages to put on, and it puts them in a line. So that might be 10 volts, 20 volts, 30 volts for these. This one here might be 5 volts and 25 volts, and another 5 volt and 25 volt. That is the charging that will go on here to charge them, to get them deflected properly onto the substrate. So we go from our bitmap character to the raster table, we look up these rasters, that there, we equate them to the voltages get sent to the print head, and then it gets printed. So that's just one character. What happens when we've got 2 lines of text, or we want to do various other things? This is where the print formats come into it. So with 1 line here of 3 in the example, that's a 1 line of 3. You cannot really do much else with that. But if we end up going to more drops, (16-drop raster). So with a 16-drop raster we can divide it up in many different ways to print many different types of print at the same time, for instance. So we could have this at the first 7. So that's 1, 2, 3, 4, 5, 6, 7. Gives me a character. I can have it at the bottom 7. Gives me a character. So now I've got 2 characters of 7 drop, and I've got a space between them. I could also have this produce me 1 big character of 16 drop if I wanted, for instance. Now, This one is 16 drops. We know that there'll be more drops printed. Therefore, it's a slower raster than if it was 14 drop, for instance. If it was 14 drop, could I do the same as I've done here to print 2 sets of 7 and a 14 drop large character? Yes, we can. So with a 14 drop, no gap between, because we've only got 14 drops here. That's a 7, that's a 7, this is a 14. So what we now have is what's called the raster switching table. We've worked out that we can charge this drop differently to that drop and force them apart to create a gap. So when I print these two, I use a raster switch 1. When I print this one, I use raster switch 2 because I don't want the line through there. I want it to be a solid character. Because now I'm using 14 drop and not 16 drop, I can print faster. And I can produce the same results as before. So these are just some of the little tricks that we do with the print formats and the rasters to produce different types of rasters. Of course, if you were doing a data matrix code, for instance, square code, you don't want lines going through the middle of it, you can't read it. So for stuff like data matrix codes, you wouldn't use that switching bit and so on. Any questions?
Yes, with the raster switching mechanism, do we compromise on the performance, speed, etc.?
No, no. These rasters, because they're 14 drop, we just have moved these apart. So you may get at the bottom end and the top end, the drops just slightly closer together, where it's got the line between them. That is a trade-off because we know we don't want it on a data matrix code, we want that to be a solid line. It's just a trade-off, there's no speed difference in that at all. It just, when it goes to fetch those voltages, it just goes to the other table to get them.
If you have multiple switching between some 1 and 2, 1 and 2, 1 and 2 alternating, would that be?
No, because inside your raster you have, for instance, 2 tables, for the 1 and the 2. So it knows for these, I just go and get the voltage from that one. For that one, I get the voltage from that one. It's not that it has to work anything out, it's a table. You can have tables like this, and say it's a very simplistic view of how it actually works. You can have them for the upright position, you can have them for reverse, because reverse is always different, and you can have them for invert, and you can have them for invert reverse. So you can have 4 tables times 2 for every raster inside there. Simplistic view of it. In some of our printers, in one that I worked on, I tried to do away with this mechanism entirely and just have numbers of drops. And so everything was 32, and it was where you put your baseline, that was then how many drops I would print.
Good question. So if we go like this, so maybe between 7th and 8th week the charge is more. So it means 2 A's will be longer than the single A. Will that have any effect on the size?
No. If you were to go down to micron level, probably yes. But for viewing, no.
Okay.
We try to make each of those 2 7s the same size.
Because there will be now a space between, 2 A's.
Yeah,
So,
there's the space that's here.
Yeah. Space here.
But
So.
the size of that and the size of that will be the same.
But if you compare it with a single A, will that be shorter than the 2?
No, because as soon as you put a single A on here, it will always go to the right raster switch for that. Only for the large ones will it go to the other one.
Okay.
Now, on some of our printers, you can actually put something across that, and you'll see a gap straight down the middle of it. But if that's what you want, that's good. Okay? So it's a very simplistic view of it, so thank you for coming.
Thanks, David.